Okay, request you to switch on your camera, please. It was excellent session. Thank you, Dr. Khalid. So today we will end up the session with a few more syntax and other stuff, so that the basic, learning of R. So the journey has not yet end. You know that it's not that today once we finish, it's like that your end. This journey has started from today. So you will be start practicing yourself, and if you have any queries, questions, we are here to support you. You can mail us, call us, or you can just that have on WhatsApp group also. You can just share your feedback, or you have some queries you can share there. So there's a lots of people there who may help you also. Let's say that in a group, somebody knowing that things which we're asking, they might help you. In case if they are not able to answer, we'll surely help you from here. All right. So like that group, that where you are already associated, we have more than many groups like that where we need to answer. So it's sometimes it happens that we are not able to answer all of the queries questions quickly, but we try. All right. So let me check if Dr. Parmar is there. Sir, you there? Okay, let's wait for him. I think he's not there. And make sure that on Monday we are starting the new session. All of you must be aware that on Monday we are starting new session. Those who want to repeat the session, please register yourself on the link given on Facebook page. And those who want to, that share with your friends and family, or maybe some connection which you think that it will be useful for them, do that. Maybe to your college students, your colleagues, or the company where you're working now, you can share them. So it will be useful for them. Let's do some good things, that, because right now the world is going through a very rough phase. All of you must aware that this COVID has, damaged many people, and many, that most of the people has been affected. Some of them financially, some of them health wise. So that it is bad phase, that which we are going through, the whole world. And so we need to, that as a good human being, we need to support our society. That's how we should, that act. And due to that reason, that the concept and the idea behind these workshop is not only, that to earn money, of course, not at all, but to make sure that what you share with your society. So we are sharing this with the global society, that the people from different part of the world, they are learning somehow, and they are doing great. They are very thankful to Dr. Parmar that the way he teaches, the way he handles. Obviously, R1, R2, R3, R4, then Python. Python, there's lots of things to learn in Python. So in data science, it's like C. So he has lots of knowledge in that industry. So I mean that you guys can also get benefited out of it. So we have tried our small steps, that small action, which might, I don't know how much it affect, but we are happy that we are doing that. That it makes us happy to support the people around the world. So I request all of you, do a small part, share it. It doesn't cost any money. Maybe people waiting for this message from your WhatsApp group or maybe Facebook group. You share. All right. So let me check again. Sir, you there?
Yes, sir.
Okay. Sir. Welcome, sir.
Thank you, Mukherjee.
Over to you, sir.
Fine, sir. Today I have vaccinated.
Oh, wow. Great.
Yeah, COVID-19.
Right.
Stay blessed, sir.
Good for you, sir. Good for you. Let me see if my turn comes, when it will come.
Yeah.
Because it's right now in India, we have I think 45 people, 45 years old. That people above 45 they can get.
No, 50, 40, above 45, correct.
Above 45.
But they are allowing the less than 45 also, because there are very now the lots of vaccination has been done already.
Okay, okay.
So there is no crowd. So they are asking even 22 years, 25 years, they are allowing them.
So what is the process like that you go directly to the center or you just do
Well,
it?
they came here in our multi,
Okay.
and they have Bombay hospital doctors put some camp over there,
Okay.
and there is 250 rupees charge only. They are
Okay.
charging, and there is a registration, and we will get one COVID-19 vaccination, whatever, after some time on our SMS.
Okay, I'll
code.
check that, sir. Because normally I try to book online, but they don't permit me because my Aadhaar card has said that you are not eligible.
No, if you go direct to the hospital, like Kips Hospital is there, the Bombay Hospital, they are allowing now, because there is no shortage of the vaccine
Okay, sir. Okay.
at all. Vaccine is available already in a huge quantity.
Okay,
So
sir.
they are allowing everyone.
That's wonderful, sir. We'll go tomorrow. Over to you. All of you, you know that it's great news for the people who is from India. There's a lots of vaccination available, so try nearby your center. That whatever center try, as sir said, so we can try, to get vaccinated. Thank you, sir. We can start.
Okay, sir. Okay, sir. Thanks. Welcome, everyone. I could not upload yesterday's video. Today I will upload the video, and I will send the link because I have keep this video public, so you all could watch this video whenever you require, and on the YouTube. So I will share the link of the YouTube, so you could watch the videos of the all 5 sessions. Okay.
Sir, yesterday you said you showed the last inner join and outer join functions, sir.
Join. Yes. I will upload the video. You could again watch that video. Okay. I made the videos public, so
Okay.
everybody could watch it. Okay.
Okay.
Rajiv.
Okay.
So I will send the. I will put the link. There is my YouTube channel. Our YouTube channel is Cypher Analytica. Okay. I just give you that link also from my channel. Just a moment. So I'm giving you the link here on the chat box. This is the link. You could go here and you could watch the videos. All the 3 videos I have uploaded up to now for these, and other videos are also there. You could see the videos on the statistics, and some other videos are there. So let's continue the session. What we have, we were yesterday we were taking the section about the analysis of the univariate analysis. So I want to tell something more about, because we have seen only the summary, 12-point summary and the 6-point summary. But if you want individually to find out the mean, okay, then what you will do? So I will show you that thing to you. So just share my screen with you first. Okay. So are you getting my screen?
Yes, sir.
So there is that seat is not there. Some more seat. Okay, this you were doing yesterday. So suppose we have to find out the mean. I just see here. You can run that. Again, I take the default data set MD, empty cars again. Okay, so you are already aware about the empty cars. I'm taking again this one. We know that we see the structure and we could find out the summary, 6-point summary and the 12-point summary through the Cyc library having the function describe. But if you want to find out the mean of one particular column, then you just have to write the mean. Okay, then MD, the data frame name. Then you put the $sign, you will get the drop down menu of the variables. Whatever the variable you want to find out the mean, you just select that and just run it. You will get the mean of that particular variable. You could find out the SD also, just write down the SD and MD dollar is the standard deviation. You want to find out the minimum value. But the terminology is very simple. Minimum, maximum. Then range. This is for only one by independent column, individual column, if you want to find out the statistics. So they are giving the minimum and the maximum. You have to subtract this value. Then you could find out the range. And mean absolute deviation. Okay. This is the standard deviation through the mean. And this is the mean absolute deviation through the median. Then you want to know about the first quartile, third quartile. So there is not a separate function for that. So we have a function like quantile. We get the 0% is the minimum value, 25% is the first quartile, 50% is the median, 75% is the third quartile, and 100% is the maximum value. Okay. You see the minimum value 10.4 here also 10.4, maximum value 33.9, 33.9. And median, if you want to know the median separately, median is 19.2 if I want to know the median. This is the 19.2 you see here. Okay. You want to know the interquartile range, so that is in capital and IQR. Few functions, only the very few functions are in capital. This is the interquartile range. The difference between third quartile and the first quartile. So 22.8 minus 15. 15.425. So we'll get this. So these all statistics you could get it easily. Sometimes what happens, we have a category, suppose in arthritis. I will tell you. I also take the data from arthritis here in my environment. Why? The library I have to first run. No, that is not a site. That is the VCD library. And then I take that. So you see there are 84 observations, 5 variables. As we know that there is only one numeric column, we have age. So you want to see the age of the male and female separately. And the sex column is here for male and female. And we want the average age of male and the average age of female. So at that moment, you could not find because it is the one column only. Age is a different column. And the categorical column is a different column. So then what we will do there? So we have some apply function. Otherwise, we use the for loop. Okay. So there are some functions we could apply here instead of loop. So you see when we write the t apply, we have the one from the library snippet and one t apply function from the base. So we have to select the t function of the base R base. Okay. So there is little bit difference in the both function t apply. So always use the base R base function, and first argument is the numeric variable we have to put. So I am writing down here the numeric variable. Okay. MD dollar, sorry, MD not DF. We are using the DF. DF dollar age. Age is our numeric. And then we have to put the categorical. Okay. So categorical is DF dollar. I use the gender. Okay. And I run it. No. What I want from this, which function I want to use. I want to use the mean of male and mean age of the male and mean age of the female. So I will just write down the mean here. Okay. Without any bracket, mean. And I just run it. So you see the female mean age of the female is 53.5 years. And the mean age of male is 53.0. Similarly, I could use also t apply or df dollar age. Age is the only numeric here in this data. We have a categorical different. So I am using some other categorical improved. And then mean. So I'm getting the none improvement has been in the age of 49.69 average age, and the some improvement 57 years age, and the marked improvement also in the 57-year age. We could also find out the standard deviation. Whatever the function you will write, you could find that. This is the standard deviation. You want to find out the minimum, would get the minimum age 23 and 27, whatever. So t apply have the three arguments. First one is the numeric variable of which we want to find out the mean or whatever. Second is the categorical variable, in which category you want to find out. Third one is the function. Okay. If you want to know anything about that syntax, you just put a question mark and write the name of that function. And just click here, you will get here. Okay, you could read the syntax, the X index function. So X is the R object of which split method exists, typically vector like allowing subsetting. So, but it gets some confusion. So I have explained you, the first is the numeric, second is the categorical, and third one is the function. Okay, there are some other arguments, but they are not usable. They are not default argument. Okay. In this way, we could see it. Now, is there any doubt, any question? Anybody want to ask something? Yes. Clear, okay. That's good. Now we start the inferential analysis. Okay. So let me start the basic or hypothesis. So generally what we do, sometimes we get the numeric data of Likert type scale. Okay. Generally strongly disagree in this way. And at that moment, we have to find out the reliability of responses. How reliable the responses, because it is the tick mark. So the the person what do, they just randomly tick mark the questions. So why we have to find out the reliability of the data, that is only for the Likert type scale or the binary dichotomous scale. Okay. But for continuous scale, if you have in your data, you have the age variable, you have the income variable, there is no requirement of reliability of data. Because it would be the right information almost, or we could not judge the reliability of that thing. So one thing is the reliability test. We perform many tests over there, but the Cronbach alpha is the one is the major. It is mostly used by many persons. Cronbach alpha is a measure used to access the reliability or internal consistency. Whatever the questions we have, the Likert type scale. Suppose we have the 25 questions. And the Likert type scale. So you will find out the internal consistency of that data set of a set of scale or the test items. In other words, the reliability of any given measurement refers to the extent to which it is consistent measure of a concept. And Cronbach's alpha is one way of measuring the strength of that consistency. Okay. To interpret alpha as a signal of reliability, the set of items has to fulfill two prerequisites. First, they have to be measure of the same latent variable, and this is only one variable homogeneity. Okay. Just like if I are taking the 5-point Likert type scale, then all should be on the same type of scale. Or it is the pre-test, we have to take the separate reliability for the pre-test, and the post-test also we have to take the separate reliability of the post. Before and after, if you are doing something like that. Okay. And if you have the three different scale you are using, then you have to find out the reliability separately for all the scales. Okay. The factor loadings have to be same. Together, these assumptions are called essential tau equivalence. So here I am using one data set I have created randomly, because it is not a hypothetical data set. Basically it is. So Likert data. Okay. So I have created one dummy data set here. So you see there are 60 observation and 11 variables I have. So first is the R1, R2, R3, and this way these are the responses. And L1 to L10 I have these 10 questions Likert type, 1 to 5 scale. Okay. And I just remove first column from here because this is not useful for me. So I'm just removing this one. So I have the 10 variables, all are the Likert, and I will show you the structure. All are integers. Okay. I have the 60 observation, 10 variables. So all the 10 variables are the integer. Now I would like to check the reliability of this. So we have the psych library, which we use, and we have the function alpha. Cronbach alpha, we are using the function alpha, and our data set name is MD1. So I am using it. So you will get here a few warning also. Some items are negatively correlated with the total scale and probably should be reversed, because sometimes we put some negative questions in our questionnaire. So those questions responses make negative correlation with the total data response. So to do this, run the function again. So we have to add this one more attribute in our that syntax. So I just copy this and I will show you where the reliability is less than 0.6. It should be more than 0.6. So that is a raw alpha. So it would be better. And here is the standard alpha is 0.6 and this all. So generally we see the raw alpha. Okay, that is important. And the raw alpha, if you remove the L1 first question, then it will be 51. It will be go down. So I think there is only the question number 6. If we remove question number 6, we will get the reliability 0.69. So it's the reliability of an item is dropped. If you drop any one of the item, you will see what would be the reliability that is showing. So either we could drop item number 6 or we could change the negative questions. We could change the marking of the negative questions, negative correlated questions, L5 items, the L5, L6 and L8. So I just copy this and I just put this in my here after comma, check dot key is equal to true, and I run it. I have already done this, so I just run this one. Okay, that is the same. So in alpha, I am given true. Some items were negatively correlated with total scale and were automatically reversed. So this is indicated by a negative sign of the variable name. So you'll see wherever the variable name. So this item has been reversed. This item has been reversed, and this item. So this 3 item has been reversed. Now you see our reliability of data has increased. It is 0.8. Okay, when you see the 0.8 is good reliability, there is only 0.8 to it. If we remove the L5, then you could increase some reliability more, but it is sufficient reliability. We could rely the data and we could go for the further analysis. Okay, does that make sense to you? So this is the very first thing, but this only we do with that liquor type scale data. And the reverse has been taken only in calculating the alpha value. Only they have taken it for the alpha value. It has not been changed the value in the is MD1. So we have to change these values in the MD1 for further calculation. So what I will do, MD $1 L5 6 minus. So if you, I will explain why I am doing this thing. Suppose I have a scale 1, 2, 3, 4, and 5. So instead of 1, I have to put 5. Instead of 2, 4, 3 would be 3, and here 2 and 1. It will be reverse. It is in the direction, or this is in this. The direction has been reversed. So what I can do, if I make 6 minus 1, I will get 5. 6 minus 2. I will get 4. 6 minus 3, I will get 3. 6 minus 4, I will get 2. And 6 minus 5, I will get 1. Does that make sense? So I am using 6 minus whatever in that. So it will be reversed 6 minus whatever the point of scale, just one more you take and subtract from that. Okay. So is there any doubt here? So I have reversed the values of all 3 columns which were negatively correlated.
It's okay, sir.
Okay. So I will run this. Now it has been changed. And second thing is the factor analysis. Generally, if you have not done the pre-factor, then you have to go for the post-factor. Yeah, we'll find out the factors. Through these 10 questions, we could make some factors. So factor analysis is often referred to as a data reduction. We are reducing the data. Sometimes we use the prefacto. Some questions are related to we are conducting some survey in a school. So some questions may be related to the academics, some may be related to the sports, some may be related to the curriculum activities, some questions may be related to the mess, means the lunch and these all things. It is hygienic or not. So there would be some questions, and we would ask those questions, and after getting the score of those all questions, whatever are in the one different factors, and then we could see which one thing is good, which one is thing is not good. So it is basically the data reduction. So factor analysis is correlational method used to find the describe the underlying factors driving data values for a large set of values. So factor analysis identifies correlations between and among variables to bind them into one underlying factor driving their values. And there's 5 questions we have included in one vector regarding the relating to mass. Okay. The 6 question here, the 7 questions related to sports activity. Some other curriculum activities, some questions are related to. We will make the bunch of that. So it is run a PCA to determine the number of factors. So we will run a principal component analysis. So it is the correlation MD1. I am finding out and giving it R name. And I will show you this. So these are the correlation. L1 with L1 is this, and this with this is this much. So this is the correlation. And this MD1.PCA, I have given the object name. You could give any object name XYZ, but the function is principal component, R, whatever we have met a correlation matrix that we use here. And then I will see the summary of this. So I will show you the summary. So it's the component 1, component 2, component 3, component 4, component 5. So they have given the standard deviation of all components. Okay. And the proportion of variance is given. Then cumulative proportion is also given. All the 10 questions, we have the 10 component. And how many variables, factor you could choose here. I just draw a plot and plot for this also. I think there is a variances of the component is already given, the proportion of the variances.
2 factors are suitable, sir.
So this we are getting here. So I hope that we don't include the 1 always in the cumulative proportion. So we have the 8 maximum factor. Okay, 8 factors we could take. So I am taking the 8 factor. The function is factanol. MD1 is my data. Factors is equal to 8, and rotation, we have the different rotation. You have to go deep in the statistics for this. You read the different varimax and some other also. And I run this. So error in factanol, 8 factors too many for 10 variables. So there are these factors are because it is the hypothetical data, so they are not basically, if we have the 45 questions or 30 questions, then we could do these all things. So I just reduce this. For hypothetically, I am reducing it. Suppose I am taking only 3 factors. So I will show you that those factors. I just want to show you. Practically, you will do it later on. So uniqueness, you see the 0.6, 0.241, 0.175. So the low uniqueness is not good. It should be 0.67, it's 0.5, and this all. So you see the factor load. If you see here, this would be in the first factor. This is the high value here, and this also, and here it is in the second factor. Okay, and L6 would be in the second factor. L7 would be in the highest value we see where we are getting. Okay, that we have to merge in that particular factor. So here you see the 596 is greater, so it would be in the second factor. Here it would be in the first factor, and this would be in the first factor. So it is not a actual data. It is hypothetical I have created on R. So test of hypothesis that three factors are sufficient. The chi-square statistics 25.36 on 18 degrees of freedom. So p-value is greater than 0.05. So I think this is not, these factors are not sufficient. Okay. If I take 2, Dr. Khalid is telling we should take the 2 factors, and I see this. There is also 0.01, so it is less than 0.05 at the 95% confidence level. You said that the 2 factors are sufficient for this. Okay. So uniqueness is also good. Most of the items. This is good one. So this is about the factor, how we could do the factor analysis and this all. Now we come to the few tests. We have some parametric test and non-parametric test. And I will not go in deep generally because it is the 5-day work. So if I want to explain the inferential analysis, it will take 3 to 4 days. If I tell you the theory behind the test. So t-test we perform on the parametric data. It is a kind of parametric test, and we have an assumption that the data is normally distributed. The population is normally distributed, and the scale is numeric. Scale is, we could say that the interval scale or the ratio scale, and we could not apply on the Likert type scale this t-test. Okay, directly. And we have 2 types of t-test. Basically 3 types we use. One is for the unpaired, and second is the paired t-test. Paired t-test we use for the pre and post, before and after, and unpaired we use for not for the before and after, and the both calculation are different. Okay, the paired t-test we calculate the column mean first. We have the 2 column. We find out the mean of the first column and find out the mean of the second column. In the unpaired t-test, unpaired t-test, we find out the mean of the first column and we find out the mean of the second column. Then we find out the difference between both mean. Okay, mean of the column 1 and the minus mean of the column 2, whatever, and we divide it by the standard error. And that ratio would be the value of the that value of the ratio is called the t value. Okay, as per the degree of freedom, whatever we have, n-1, or here in this sort of case n-2 unpaired. So we check that. As per that, we check in the table and we find out the p value. So if our t value is greater than the table t value, our t value is greater than the table t value, then our null hypothesis would be rejected. But better way to understand, in the R and in Python, in the other programming language, we got, along with the t value, we got the p value also. So we should go with the p value. If your p value is greater than 0.05, then your null hypothesis would be accepted. If it is less than 0.05, it would be rejected. So I will explain you this. Yes, script plot, eigenvalue, everything could be done in R.
Thank you, sir.
everything. So we will cover this on our succeeding classes. So I am taking one data set which is a wine quality. So I will see here whether it is equal. Okay. Or this wine quality data, we have the 4,898 observations, 12 variables. I will explain you that. The fixed acidity in the wine, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH value, sulfates, alcohol, quality of the wine. And we could see the structure of this. We know that most of the variables are numeric. Only one is integer. Okay. So I will show you the table of our target. Generally, the WQ dollar quality. So we see 3, then 4 quality, 5 quality, 6 quality, 7 quality, 8 quality, and 9 quality. Okay, well, these are the samples we have from those quality. So here I am taking the one sample t test, and government has given some value. The fixed acidity must be, should be 6.10 near above. So we have taken the sample from different tables and the data we have, and through that data we see whether their average fixed acidity is equivalent to 6.10 or not. Is there any significant difference? So this is our population mean, which has been given by the government department. And this mean, we will find out the mean of this. This is the sample mean. It will automatically will calculate it in the t-test. So I just run this. So you see, if I read the null hypothesis, what I have written, there is no significant difference between population and sample mean of fixed acidity. Okay. So I run it. Sorry, I run it. And why I am not getting that? Okay, it is running. One sample t-test, data, fixed acidity. P-value is 62.598. Degree of freedom at 4897 because n minus 1. 4898 minus 1, 4897. P-value is less than 2.2. E is for 10 to the power minus 16. 2.2 into 10 to the power minus 16. So it is negligible. So this hypothesis, if you see the alternate hypothesis they have given, the true mean is not equal to 6.1. Okay. True mean means our actual mean from the data is not equal to 6.1, but our null hypothesis, there is no significant difference in the both mean. So it says that its value is less than 0.05. So our null hypothesis has been accepted, rejected, and the alternate hypothesis has been accepted. Say true mean is not equal to 6.1. Means there is significant difference in sample mean and population mean. Okay, as per the fixed acidity. Does that make sense to everyone? Any confusion? Is the 95% confidence level is given and the mean of X is given. The population mean is already, we know that. Any doubt? So this batch would be rejected. This batch would be rejected because there is a significant difference between population mean and the sample mean of fixed acidity. Okay. Second, it is on this interval is for 95%. If we want the 99%, then we have to write here conf dot label 0.95, 0.99. So what we get here, we will get this interval will change only. The other value would remain same. This will remain same. Degree of freedom, p-value, everything would remain same, even the mean, but this value will change. So the region will expand. Acceptance of null hypothesis region would be expand. Okay. Okay, please. There is some noise already. So I hope Celis, mute yourself. Okay. So I have explained you how we could use it. Sometimes we have one tail test, and this one tail test, you see, I have written one null hypothesis. The sample mean is not less than population mean, or alternative sample mean is less than the population mean, left tailed. Okay. So we will use this attribute alternative equal to less. Okay. So you see the alternate hypothesis written, the true mean is less than 6.1. Means our actual mean is less than 6.1. It is our alternate hypothesis. The t value is given, the p value is given, and this the mean is given. So we already know the mean of x is greater than is less than 6.10, 6.8, or it is greater. It is greater than 6.10. So it is 1. True mean is less than 6.1. So p value is more than 0.05. So our null hypothesis has been accepted. So null hypothesis is that the sample mean is not less than population mean. So sample mean is not less than population mean. This has been accepted because the p value is greater than 0.05. So what it is, there any doubt? And
It's okay, sir.
if we are taking the just opposite of that, the sample mean is not greater than population mean. So we run this and we are getting p value less than 0.05. So our null hypothesis has been rejected. So because we already know the actual mean is greater than population mean. Does that make sense to everyone? Because this portion, the inferential analysis is better for the academician. I think most of you are the academician here in this batch. So you could better understand. I don't have to tell the basic concepts of these all things. Okay, just I am telling you how to operate the commands in R, or we could get the very good statistics here. Nothing remain. You get all the things. You copy this, you paste it, then you convert this in table. So I will show you few tables how we could convert this. We copy paste this in table. We have a different techniques to convert this in table. I will see some results must be there in the sum because I also work with the laptop. So most of the things in my laptop. So this is the PhD analysis sum. The results are 32 respondents. So this is the descriptive one first. These are the reliability of the various, the control group pre, control group post, experimental pre, experimental post. The inferential analysis I have just put here, that copy paste, but this is not the actual one. We convert this in table. Okay, so I will see where that file is, or it may be, it is not here because it was in my laptop, and I will show you some other if I get. Okay, I'll show you on my mail. It should be on the mail. Just a moment. It should be. You see, this is the same what I explained you, but the table is like this. The infantil analysis, there is no significant effect of hypnotherapy on complex trauma in the orphan children. So because it is basically the pre-post, and we are giving this, so it is the pre-post I have just given here, but it is not. I will take some other. It will be better. Just a moment. Right, so that. These are some other pages. So this is the continuous variable. We use this is the through the R I have taken this figure, and then I have given this as summary of the control group and the experimental group, and this all. This is the all R visualization. Very pretty visualizations are there. You see, this is the because it is something like that. A different. It is the non-parametric test I have used here. Glucose test. Okay, and I will show you that test. T test. I will show you. No, this is not that. This is not that. I will show you that. Just a moment. I changed the figures. I have changed it here. Here I have done that changes. Because it is a pair test, a pre and post. So we are not using the mean, we are using the box plot, and we are getting the here the pre was this value and the post is this value. So this is in that way. This is the new sort of graph we are using. Got it? So in the peer t-test, what happens? We find out the difference between pre and post of the each observation, and then we find out the mean of difference, not the difference of mean. In the unpaired t-test, we find out the difference of mean, x1 bar minus x2 bar, and divide by standard error. But in paired t-test, we find out the difference first, and we find out the mean of that difference only, and then we divide it by standard error. So there is a major difference in both. Got it? So that is the peer t-test. So we are using this sort of graph, and it is not a peer t-test because there is a control group and the experimental group. Both are the pre-scores, so both groups are different. So it is the unpaired t-test. So we could get the mean and the standard error we could show here. So graphs are different. So here you see we are showing the mean, standard deviation, t-value, degree of freedom, and p-value. In this way, we have to make the table. For the unpaired, I will show you. We are making the pre and post and the mean of differences. This is the mean of we are not writing the mean of the both variable. It is the mean of differences and t value and the degree of freedom and p value. So in this way, we could write those value, copy paste here, we could type here, and then we could interpret it in this way. Okay, there are some other tests I have also conducted. There would be significant reduction of other such variables, nausea, vomiting, blood pressure, and happiness. So this is one correlation graph, which Dr. Khalid asked me yesterday. You think that? Yes, Dr. Khalid. So you see, I told you we have the various sort of graphs for the correlation. So this is one of that. Okay. So here in the diagonal, we get, if it is continuous, we get the histogram and density curve. And if it is categorical, then we get this bar plot. On the upper triangle, we are getting the correlation. Okay. This is the happiness and NVP. The correlation minus 0.01. So there is very low degree correlation. Everything is the low degree correlation. So this is given that also our p value is 0.9122. There is no significant correlation between them, happiness and NVP. And there is the NVP and blood pressure is also not significant, and blood pressure and happiness is also not significant. So this is the some diastolic blood pressure and these all things. So this is to be done. The interpretation is to be done. I have to set this thing. So this is a way we do the thing. We get the result from here. We can we put in table. Sometimes we don't put it table. It depends on the guide what it says, what sort of formation he require. Because I will show you one more. Because whenever we have very too much we have too much hypothesis. Suppose I have the randomized experimental design. So I will show you the result of that. So this is a randomized design of 2 by 2 by 3. So these are the two edges we have divided in two parts. So it is 2. Gender is male and female, 2. And the birth order is 3, single, younger, and elder. So 2 by 2 by 3 randomized block design. So I have taken the EMS early adolescent male single, early adolescent male youngest, early adolescent male eldest. So in this way, I have given the group name A, B, C, D, E, F, and this is the 111 cell, and in this way. And then we are going to do, so there are 584 hypotheses in this project. So first, along with the demographic variable, the age and gender and birth order, we will use the ANOVA. And these 7 hypotheses, I am using the ANOVA, and the others 2 are having the significant difference. So we do in a different way. We write, because the 584 hypotheses, if you explain separately and give the graphs for each, so it will take more than 600-700 pages. So we use some tactics here, and then we perform the detailed result. We compare group A and group B. Means single early adolescent males do not differ from younger early adolescent males, B. And then A to C, A to B, A to C, A to D, in this way. So whatever I have here, you see I have the 12 up to L. A to L I will see, then B to L I will see, then C to L I will see, and D to L and E to L, F to L. In this way I will get. I think that in every, or there are 7 factors. One is the total score and 7 factors. So 8 I have got here. So I have to make in that way. So it is the space is the main total. And so we are not putting whole table here. You see what I want to show you that. So it has been accepted. Null hypothesis is accepted, so we don't have to describe anything. We just put that value. We just put t value. We are not writing anything. Okay. And whenever it is rejected, then we are using p-value, and here something is missing. I think that why it is so, because we are putting both mean also here, but it is not showing. Okay, I will just see. I will just see. Just see. I think it should be there. Why it is not showing? Okay, it may be possible. I just download it, then it will show. I think that here it is not showing. Put it desktop, and then later on I will create this. You see, this is the mean of A to E. So the mean is I have given, and the p-value is less than 0.01. I have just shown this, and the t-value I have written. And younger early adolescent females are significantly more stressed than single early adolescent males, because as per the mean I have given this interpretation. So in this way, the very small space it will take. We have the 584 hypotheses are there, and it used 113 pages. I have not used any graph up to now. I have to make the graph of the mean of the all factor wise. Just I will give the 8 graphs. Only the 8 graphs I will show here in this PhD. So it is the randomized design. There is a grand summary, and this all has been written, but I will not explain more thing here. So I have this would help you in your work. So now we take one more. This is the one sample t-test we have performed. Now we do the another. I am taking another file. This is the hsb2 dot says 7b data. I will show you the view it. So it is the ID, female, race, SES scale, socioeconomic status, school type, program, read, write, math, science, social science. This is the data of some school. Okay. So first we are taking here, there is no significant difference in writing and reading skills of the student. So it is a paired t-test. The same school, same student reading and same student writing I am talking about. So we have to mention here paired is equal to true only. Other thing is same, the first variable and the second variable. Okay. So I just write here and run it. Paired t-test, both the variable t value, degree of freedom 199, p value which is greater than 0.05. So null hypothesis accepted. There is no significant difference in reading and writing of the students. Okay. Mean of difference is given. So this is a way we could perform the t-test. It's very easy in R. Now I will show you the unpaired two sample t-test. So alcohol percentage are significantly difference between wine quality 3 and 9. Wine quality 3 and 9. Okay. So we make one null hypothesis for this. This is our objective or problem. There is no significant difference in alcohol percent between wine quality 9 and 3 and 9. So what we have to do, we'll first make you the table and I will show you. It is just for our sake of knowledge, I am making that table. So wine quality 3, we have only 20 samples, 20 observations, and 9 we have the 5 observations. Okay. So it is basically unpaired t-test. but it's not pre-post. So we will make one column for the alcohol. Okay, for wine quality 3. So alcohol underscore quality 3. So wine quality alcohol, what observations we have to select? The wine dollar quality equal to 3 observations we want only. And also for the 9. So I will show you this. If I run this, so you will get this 20 observations we have got. And the 9 we got the 5 observations of the alcohol. Okay. So now I have the single variable this. So I will show you the length 20 and 5. And there is no significant difference in variance of both. So first I will perform the variance test before t-test. So you know that it is 0.77. So our p-values of a null hypothesis is accepted. True ratio of variance not equal to 1. So here is the true variance of ratio is equal to 1. So true ratio of variance is equal to 1. So we have to mention as an attribute the variance dot equal to true. Then it will give us the correct. So you will see here. So it is the t-value, degree of freedom n1 plus n2 minus 2. So n1 is 20, n2 is 5. So it is 25. Minus 2 is 23. So degree of freedom is correct. P-value is 0.005. It is less than 0.05. So there is significant difference in alcohol percentage of wine quality 3 and 9. Okay. So in this way, we could perform it. So just you read it and you try. I just came in 2 minutes. Okay. Yes. So this was all about the t-test. I explained you unpaired t-test, paired t-test, and one variable t-test. Now we come to the ANOVA. We know that ANOVA we use for between if you have the multiple category, one-way ANOVA and the two-way ANOVA we use generally. Analysis of variance. So moment. So alcohol is our numeric variable, and the quality, we have a variable having characters, so we convert them in factors. So we are writing the factor quality, and data is wine quality, WQ data, and I am giving the name fit. So this whole output. So I run this and I see the summary of this. So you will see the summary of the degree of freedom, sum of square, the mean square, F value, and the P value. So it is less than 0.05. So there is no significant difference in the wine quality. Okay. There is no significant difference in the wine quality with respect to alcohol overall. Sorry, there is significant difference. Sorry. It is less than 0.05. So there is significant difference in the wine quality. There may be difference in the 3 to 9, maybe 3 to 8, but may not be 3 to 6. So it is not a complete, but the overall whole, if someone, if any one peer it is getting there is significant difference, the ANOVA will say it is a significant difference. So generally I don't like ANOVA. I like the pairwise t-test instead of this. So I will show you the pairwise .t.test alcohol and the quality, and p adjustment, one zero method I am using here, probability adjustment, p value adjustment. I am taking that. So between 3 and 4, these are all the p value. So there is value is 1. It is not a correlation coefficient. Understand? So it is the p value, which is greater than 0.05. So there is no significant difference in the alcohol between quality 3 and 4. 3 and 5, there is no significant difference. 3 and 6 also not significant difference. But 3 and 7, there is significant difference in alcohol. 3 and 8 significant. 3 and 9 significant. Similarly, you could compare here. 4 and 5, there is significant difference. 4 and 6, and every we have. Here also 5, 6, and 7, there is no significant difference with 8 and 9. 8, there is no significant difference. So I think the pairwise t-test, I feel good, better than ANOVA sometimes. Now we come to the chi-square test. Chi-square test is based on the frequency. We have the 3 types of chi-square test. Generally, we first is the test of independence, goodness of fit, and the test of homogeneity. So we have the different uses of this. So we see here too. There is no significant difference in actual and proposed distribution. So suppose we have a table of race 1, 2, 3, 4. So in the, suppose we could hypothetically think that the Asian and American, and this all the race means that does that mean. And generally we could also, in the Indian scenario, we could see that it is the general category and scheduled tribe, scheduled caste, other backward, and the general. So it is the scheduled tribe, scheduled caste, other backward, and general category. So it is the race we have seen. The actual, we have this much admission of the students in that school. And if we see the proportion of this, so it is the 0.12, it is 0.05, it is 0.1, and it is 0.725. Okay. And I do the chi-square test. Suppose the government has a different distribution. Government has assigned that there must be 10% scheduled tribe and 30% scheduled caste, 10% other backward, and the 50% general. So this is the proposed distribution by the government, community distribution, or this is our actual, this table we show as the actual distribution. So we are comparing the both distribution are same or similar or not. So this is the goodness of fit. Goodness of it. This distribution we see it is fitting in this distribution or not. So chi-square test, we write the first table and the second this probability whatever you have. So we see it is the table, the x squared value is 61.06, degree of freedom is 3. So degree of freedom is the C minus 1 and R minus, number of row minus 1 and the number of column minus 1. So it is not like that here, because here is we are taking the goodness of it. So we are having the 4 minus 1. Okay, 3. And p value is this. So this is very, very less than 0.05. So there is no significant we could say that there is no significant difference in the actual and proposed distribution. It is showing that, or it is showing that there is significant difference because our null hypothesis has been rejected. So there is significant difference in the actual and proposed distribution. So the school has not taken the proper admission of the children. Now we see test of independence. So in the ACS scale and the gender. So there is no significant relation socioeconomic status and gender. If you run this, the formula is same for both. So you see here the 0.10, so it is greater than 0.05. So there is no significant relation in socioeconomic status and gender. And there is no significant relation in both. And here also we are doing with race and SES. So we are getting one warning. Why this warning we are getting, I will show you. You see the few of the frequencies are less than or equal to 5. So the chi-square test, we generally use the yet correction over there. But we have the Fisher test we could apply instead of chi-square, and we could get the result in a proper way. So that is the p-value, and we are getting this much. Okay. So it is 0.007. So there is a significant difference, significant relationship between race and socioeconomic status. The some particular race people are having the high socioeconomic status, and some particular race are having the low socioeconomic status, like this way. So these are the thing we could use this test. Okay. So these were all about the parametric test. Now we see few non-parametric tests like the Wilcox test. Okay. So I am making one variable W, Likert type scale 1 to 500 observations and replacement to X, Y, Z for variables I have, and then I am converting, then merging them in a data frame, and I will show you the data frame. It's like this. So this is our Likert type scale, and I will use the Wilcox test between Z and W. This and this question, these two. So I could perform this, and I get this way. The p-value is 0.004. So there is no significant difference in the opinion of the question number 3, W, and the question number Z. So this is the non-parametric. Just like a ANOVA, we could use the Kruskal values test in non-parametric. So I want to compare these all together, whether there is significant difference or not. So I will just write the data frame and I will get it. The p-value is 0.29, so there is no significant difference in the opinion of the people. The all questions together. If we require only the 3 questions, then you have to make a sub data frame. You have to deselect that particular what you don't want, or select whatever you want. So this is the deployer. I have not explained the deployer to you up to now. So it is the pipe2 function, and we are selecting W, Y, Z, and because I have not run that deploy library, so I have to run it first, and then I will run. Then it will give me that. So it is the D1. I have first 6 observation it is showing me in the head, and the Kresker value test I am working on the D1. So it is 0.19. So there is no significant difference. Okay. So I think this we have done yesterday. Core plot, core engine. So this is the difference of plot. Here in this way, there are various correlation plots in R. So this was all about the influencer. If you want to ask something, you could ask me. Yes. Yes, anyone would like to ask, could ask me the question.
Sir, just tell me the regression command in the R.
Regression.
Yes, sir.
Oh. Suppose we have a data wine quality. No? Okay. We have this data wine quality. Okay.
Yes. Sir, please share
And
the
suppose we
screen.
have a target variable is quality.
Sir, please share the screen.
Okay. Are you getting my screen now?
Yes, sir.
So there is a quality is our target variable, which is y. Okay, sir. This is the dependent variable, and other all the independent variable. Got it, sir?
Yes, sir. Yes, sir.
Or we want to see whether which one it should be. So what I do, I take a new script. So there is a LM function I will use for the linear regression. Okay. And I will write here the formula, whatever I want. So what is my target variable? That is a quality. Okay. Quality. And tilde dot. It means other variables, whatever I am using, would be independent variables from fixed acidity to all, except quality. Got it? Because we have all our numeric here. I'm just giving you the introductory, not the detail, because it will come later on. And then data. Wine quality. Is it clear, sir? Up to now?
Yes, sir. Yes, sir.
I run this. It would be better to give some name. So generally I give the model fit. And I will see the summary of fit. Okay, generally we have to see the summary. So it is better for us if we generally directly we run and we are not giving any object name, we will get these intercepts only. It is the beta 0, it is the beta 1, beta 2. Generally the linear equation is like this for the multiple regression. This is the y kept the predictive y is equal to beta 0. It is the intercept. And then beta 1 x1 is our first variable, beta 1 is the coefficient of x1, just like fixed acidity is x1, and this coefficient is beta 1. Got it? Beta 2 x2 and so on. We have the k variables, so beta k or xk. So this is our linear regression final. Got it? So these all we are getting here, but we want to do some good thing on this. So I will show you that thing, how we could improve the model. So you see where there is no asterisk, these variables are not significant. Got it? These are not significant. They are not significant, making any impact on your target variable. So the which value is highest here? The 0.81, 0.65, 0.44. So the 0.81 is the highest one. So we will remove this citric acid from our linear model. Got it? First, one by one we have to remove. We don't have to remove all three. So I am removing the citric acid. I just copy this. Just a moment. I just copy this. And what I do, I will just minus. Dot means I am taking all the variables except quality is independent, and then I am subtracting, I am removing, not subtracting, I am dropping the citric acid. So I have now one less variable. I run it again and I see again the summary. Still I have two variables. So 0.66 is greater. So I will remove the chlorides. I will just copy this. I just write here without any comma using minus sign because we are removing. And I will show you. Again, you see, we are again still getting here. Total sulfur dioxide is not significant. Just a moment. Is also I subtract here. Now this is my perfect model. Now I'm getting. So
Thank you, sir.
We could write in this way. The writing technique, you could write there the quality is equal to 1.541 into 10 to the power 2 plus 6.810 into 10 to the power minus 2 into fixed acidity. And plus, then write this plus minus is minus. So we have to put here minus. Okay, because this is the minus. We are adding. So plus and minus minus. Then 1.88 and so on. In this way, you have to write that equation. Is it clear to all?
Yes, sir.
There are some more things we will discuss in the machine learning where we tell this linear regression model we create. So I will explain you these are a residual standard error and this R squared value, adjusted R square value and everything. I discuss over there. We always, we could not ignore these all things while we do this. But in a simple way, because here we have not divided the data into part. It is just for the inferential purpose we are using this linear regression. So there is, or you could search this all thing. What does it mean in the linear regression? And so this would be in detail in that. Anybody, something else? Yes. Prato, do you have any query? Your mic is mute. Please unmute your mic.
Thank you, Professor, for the lectures. But for me,
Yes.
I'm a beginner, as I told you yesterday, and I start from the beginning, from the video record.
Yes.
So I want to watch again for those lessons, and then I hope.
Okay, we are sharing.
will get a
I
good-
have shared that also. Mabratu, I have shared the link here in the chat box. You will see videos link. Look at in the chat box.
Where is that?
Chat box. Chat box is there. Chat is written somewhere in the.
No, no problem. I'll get the video records from the YouTube.
Yeah, YouTube. You will get all my videos
Yeah.
of the all sessions. You
Yeah,
will get
I
there.
received yesterday's link through.
I
yeah.
will upload it. I forget to upload.
Yeah.
Today I will upload both the videos, yesterday's and
Okay.
today's videos. Okay.
Thank you. No problem.
Swapnaja, do you have any query, any doubt?
No, sir. You really teach very well and clear all the statistical applications.
Okay.
It will
So
be
I have
useful.
mentioned the YouTube link here.
Yeah, I got.
Or I have done. I have opened it for publicly. Okay, so you could watch the videos over there. No, don't worry.
Yes, thank you.
So
sir.
all of you could watch the video. You could
Okay.
go to that link, YouTube link. Please you copy and paste it.
Yes, for sure, sir.
Okay. And you could watch the video whenever you want some confusion, you have any confusion and this all thing. Okay.
Sure. Sure.
So I hope Mr. Mukesh would be there so we could wind up the session with him. Mr. Mukesh, are you there? Yes. Yes, the Mukesh is just coming. So wait for a minute. He's just coming on, and we could see the whatever our further programming, the further workshop. So you could get the information about that. Just a moment. Just call him. That.
Sir, is there any Python session will be there in upcoming? Please unmute, sir. I'm not getting.
Yes, sir, I'm here. So are we done for the today's session, sir? Parmar sir, you there? Can you hear me? You need to unmute yourself.
Yes, sir. Yes, sir. I am
Yeah,
here.
okay. So are we done for the today's session, sir?
Yes, sir.
Okay. So all of you, thank you very much for your presence during this session. And especially thanks to Dr. Pramar that he has given an effort, that to wrap up the things so nicely. And anybody has something to say, please say 2 words.
Actually, it's very interactive session and all statistical applications explained very well. And I'm very happy with the short-term workshop and would like to join the next intermediate course as well. And
Sure.
if there will be any Python class, then I would be happy to join that as well.
Thank you. Thank you. Thank you.
Thanks, Dr. Saab. Our sessions are wonderful, and at least myself has learned a lot of things regarding data analysis. Thank you, sir.
Thank you. Thank you, Dr. Khalid. Yeah, Mebratu, unmute yourself.
You need to unmute yourself, Mevratu.
Thank you very much for today's lesson, and I hope we will get this video recording also from YouTube, similar with the previous one. I received that one,
Yes, yes.
and then I will receive also this one.
Yes, yes.
Sure.
Thank you very much, and miss you all.
We'll miss you.
Yes, yes.
How is India?
All
Fine,
good.
fine. It is running under COVID.
Indian people is lovely, is very sociable and cooperative.
Yeah, yeah.
So do Ethiopian people, by the way.
Of course.
Thank you. One day I will visit India. I hope. I'm searching PhD scholarship, so I hope we'll
Most
meet.
welcome.
Nice,
Most
nice.
welcome.
Most welcome.
Okay. Thank you very much.
Thank
Yes.
you. Anyone
So
like to
the
say?
last class is on Monday,
Monday we are going to start next one.
so we will finish this topic on Monday.
No.
No, no, we
today-
have finished today, na? We have finished it, na? Inferential analysis. We have finished this topic.
Okay. So when we'll finish this? Today?
Today we have finished it.
No,
Yes,
our
yes.
program is up to April 5 or like that.
5 days, na?
Yeah.
So,
So
Monday
Monday to
to
Friday.
Friday, the session was that, and today was the last day of the session. By the way, 5th April we are starting new session. Same course will be get repeated. In case
Okay.
if you like to get repeat that, you can do it, or you can recommend your friends to do that.
Okay. Okay. No problem. Thank
I
you.
really appreciate the way you are spreading the knowledge and giving your precious time in this lockdown.
Thank you.
Thanks,
Thank you.
thanks,
That's
Supraja.
It's really appreciable, sir.
Thank you. That's all we all can do. That's all we can do. At least we should spread. That what we know, what we capable of.
Yes, sir, for sure.
Yes. Thank you. Anyone else like to say something? All right. So, sir, we'll take permission, sir. Thank you very
Yes,
much.
sir.
Thank you very
Thanks.
much. All of
Thank
you. Take care. Have a nice evening. Bye bye. And love from
Okay.
India. Again, bye.
Goodbye.